Hi everybody, in this video we're going to look at algebraic fractions. We're going to look at multiplying and dividing, and then we're going to look at adding and subtracting as well. So let's dive straight in. As I said to you before in previous video, looking at algebraic fractions, you want to try and factorise where you can. So we're looking here, two numbers that add to 8 and multiply to give me 15. So factorise the top, so it's going to be x plus 5 and x plus 3. The bottom obviously doesn't factorise, so I'll leave that as it is. Remembering here at this point that this is the difference of two squares. So what we've actually got is x plus 6 and x minus 6. So if you have an expression there where it's an x squared minus a square number, so x squared minus 16, x squared minus 25, you square root this value here. One becomes a positive, one becomes a negative. Put it in brackets. The bottom, I'm looking for two numbers again that add to minus 3 and multiply to minus 18. Thinking about what multiplies to 18, there's not many numbers, 1 and 18, 2 and 9, 3 and 6. 1 will be positive, 1 will be negative because of the fact it needs to multiply to give me a negative 18. So in this case, this becomes x minus 6 and then x plus 3. So all of that's now been factorised. What I can do is just tidy this up a little bit and write it in brackets all next to itself, because effectively when you're multiplying with fractions, all you do is multiply the top by the top and the bottom by the bottom. So I end up having these values here. And then from this point, all you're looking at doing, as we did in the previous videos, which was simplifying algebraic fractions, you're looking at what effectively divides by itself. So x plus 3 and x plus 3 divide by itself to give you 1. X minus 6 and x minus 6 divide by themselves to give you 1. So they effectively cancel out. And then x plus 5 and x plus 5 cancel out. So your answer for this question will end up just being x plus 6. Now technically that's x plus 6 over 1. But we can leave it as x plus 6, and that would be your final answer. So let's now look at the next example where it's a division. Key thing to remember is with division, we're going to be looking at KFC, so that's your keep, flip, change. Now, what I mean by change is we change the sign, we flip the second fraction, and we keep the first one the same, okay? So thinking about that again, we're going back to our factorising. So two numbers that add to give me minus 4 and multiply to give me minus 21. One will be a positive, one will be a negative. So this becomes x minus 7 and x plus 3, because minus 7 plus 3 gives me minus 4, but minus 7 times plus 3 gives me minus 21. The bottom is staying the same, can't factorise that at all, but always think to yourself, can I factorise? Obviously in this case I can't. Now I'm going to leave this second fraction the same for a minute and factorise it first. So like I said to you here, this is the difference of two squares because you've got an x squared and then a negative square number, x squared, negative square number. So the square root of 49 is 7. So we have x minus 7 and then x plus 7. And then we go back to this more complex form of factorising here. So in order to factorise the bottom, I do my a value times by my c value, which is minus 30. So I need two numbers that multiply to give me minus 30 and add to give me minus 7. Again, both of these will actually be, one will be negative, one will be positive. I know that 10 and 3 are going to be my two numbers, but I need to get my signs right. And my shortcut for you here is that you take whatever the a value is. So I'm just going to come down here and we'll rub this out in a second. And you put 2x in both brackets. Because I know my two values are going to be minus 10 and plus 3. Because minus 10 plus 3 gives me my minus 7. And minus 10 times plus 3 gives me minus 30. I put both of those numbers in to my brackets. From here, what you're looking at is which bracket simplifies. So the first one can divide by 2. So this becomes x minus 5. This one becomes 2x plus 3. So that is now the bottom factorised. So x minus 5, 2x plus 3. This, as I say down here, is our shortcut to factorising when x squared is greater than 1. If you need a recap on that, look at one of the other videos I've done on factorising when x squared is greater than 1. I'm just going to remove this bottom section now, just so it's out of the way. So from here, you now need to look at using your KFC. So we're going to keep the first fraction the same, so x minus 7, x plus 3 all stays the same, over x minus 5. We change the sign to a times, and now what we do is we flip this upside down. So the bottom goes on the top, and the top will move to the bottom, x minus 7, x plus 7. And then from here, following the steps that we basically did over here, so we're saying x minus 7, brackets x plus 3, brackets x minus 5, 2x plus 3, all of that is over x minus 5, x minus 7, x plus 7, and then we're looking at what effectively cancels out. So we know we've got an x minus 5 and an x minus 5, which again, x minus 5 divided by x minus 5 technically gives you 1, but for the purpose of this, we're looking at the fact that they cancel each other out. X minus 7 cancel out, and there's nothing else there that cancels out. So your final answer will be x plus 3, brackets 2x plus 3, all over x plus 7. If it asks you to put that in a particular format, so if it was asking you perhaps to express it in the form of what a quadratic would look like up here, where it's got an x squared plus a b value plus a c value, you'd expand the top out and then put it over x plus 7. But in this instance, we're just leaving it like that. Okay, so that's your multiplying and dividing. We'll look at adding and subtracting next. So let's dive straight in and have a look at what we need to do. So thinking about your rules of fractions in general, what you need to remember is that when you are adding or subtracting fractions, the denominators need to be the same. So all you need to think about doing is multiplying the whole of the first fraction by the denominator at the bottom on the other side. And I'll do the same here. I multiply this by the opposite denominator. Now, what you need to remember is whatever you do to the bottom, you have to do to the top. So effectively what I'm saying is I'm multiplying that first one, the top here, the numerator, by x plus 5, which is what I've done there. And then you need to multiply the bottom, so x minus 4 is already at the bottom, by x plus 5. So put it like that. And I do the same on this right-hand side. So 1 multiplied by x minus 4 becomes 1 brackets x minus 4. And then x plus 5 multiplied by x minus 4 gives me x minus 4 there. So now technically your denominators are the same. You just expand the top, which is what I would be doing there. If that number was greater than 1, that's what I would be doing. But that then gives me x plus 5 at the top there, plus x minus 4 at the top there. And now because the denominators are the same, I can just leave this all as x minus 4 brackets x plus 5. I'm leaving it all factorised at the moment just to make it a little bit easier for myself in case I need to do anything later on. Now it's a case of collecting your like terms. So look in here, x plus x gives you 2x. And then plus 5 minus 4 ends up giving you plus 1. And then that's all over x minus 4 brackets x plus 5. Now if you wanted to, you could expand the bottom out there. So leaving the top the same, 2x plus 1. If I then expand the bottom out, x times x is x squared. X times 5 is 5x. Minus 4 times x is minus 4x. And then minus 4 times by 5 is minus 20. So that then becomes x squared plus x minus 20. So you could leave the bottom in this format as well. Either of those answers would be acceptable as to your final answer, depending on if it asks you to give it in a particular format. So that would be your adding. Now, if you're looking at subtracting, the first step will still be the same. So I'm going to multiply all of this by the opposite denominator, which is x plus 3. I'm going to multiply all of this by the opposite denominator, which is x minus 5. So at the top, that becomes 7 multiplied by x plus 3. The denominator is going to be x minus 5, and then x plus 3, minus 1 brackets x minus 5 over x plus 3 brackets x minus 5. So I'm showing that I understand I've got to make the denominators the same. So you would now expand the top out here. So you end up with 7x plus 21. Now I'm going to leave that in brackets because of the fact that there's a negative involved here. I want to make sure I don't make any mistakes with the fact that I've got technically a double negative. So I'm just going to leave this one in brackets as well. So effectively 1 times x, 1 times 5. But that minus is staying in the middle. And because the denominators are the same, x minus 5, x plus 3 is what I can leave the bottom as. So now follow through your process of collecting like terms. 7x minus x means I have 6x at the top. And this is where you need to be careful because you've got 21 minus 5, which means you actually end up having 26 because when you've got a minus and a minus together, that turns to a positive. And then the denominator will stay as it is, x minus 5 brackets x plus 3. Or if you wanted to and you wanted to expand the bottom, you could put your answer as x squared plus 3x minus 5x minus 15. And then tidy that up, x squared minus 2x minus 15. So x squared minus 2x minus 15 would also be an acceptable answer as well. So that or that would be your answer for adding and subtracting. Key thing here is just be very careful when there's a negative involved. I would, once you've expanded the top there, leave that in brackets. And then once you've expanded the top there, leave that in brackets. So what you're doing is making sure that if there is a negative involved and 2 negatives, you can correctly identify that you then need to do 21 plus 5. Okay, so that is your adding and subtracting with algebraic fractions.